Hydrogen, a diatomic gas having the formula H2, a gas which was discovered by Robert Boyle. Let's see how we can prepare hydrogen gas by different methods. Hydrogen was named hydrogen, as in Greek, hydrogen means water. Since it is a water former, so from hydrogen we can form water. And from this water we can get hydrogen back. How we get hydrogen back from water? There is a technique known as electrolysis. How electrolysis takes place, we'll study later. But in this experimental setup is used. Electric current is made to pass through water. Two gases are released at the two ends. The bubbles rising from both the ends show that two gases are being released. Both the gases are collected in different test tubes to test for the respective gas. So now we'll test for the two gases. One gas which was released at one end is hydrogen, as it burns with a pop sound. This is a test for hydrogen. And the other gas which was released at the other end, it rekindles a glowing splint. This gas is oxygen. So a test for oxygen is that it rekindles a glowing splint. So when we pass electric current through water, it forms its two constituents, that is hydrogen and oxygen. So from hydrogen, when hydrogen burns in oxygen, it forms water. And when electric current is made to pass through water, it gives its constituents back. That is, we can get hydrogen and oxygen from water. So this is one of the techniques to prepare hydrogen gas. Another way to prepare hydrogen is by the action of water on metals. So when metals react with water, potassium, it exists in the form of K+, H2O is H+, OH-. So unlike charges attract, it forms KOH and hydrogen gas is released. So when metals, they react with water, they form the corresponding hydroxides and hydrogen gas is released. Sometimes cold water does not react with some metals. Some metals do not react with cold water. They need intense conditions. They need steam to react with. So such metals like magnesium, zinc, iron, when they react with steam, they form the corresponding oxides and not the hydroxides. So when magnesium reacts with steam, it forms magnesium oxide and hydrogen gas is released. In all the cases, when metals react with steam, they form the oxides and hydrogen gas is released. So when metals react with cold water, they form the corresponding hydroxides and hydrogen gas is released. Some metals, they react with steam to form the corresponding oxides and hydrogen gas is released. So the action of water or steam on metals always evolves hydrogen gas. Another way to prepare hydrogen is by the displacement of hydrogen from the acids. Displacement is done from the activity series. As we see, the metals on the top are more reactive as compared to the metals on bottom. So the more reactive metals can displace the less reactive metals. This means that hydrogen is here in the metal activity series. All the metals on top of hydrogen are more reactive than hydrogen. So they can displace hydrogen from the acids. Let's see how this takes place. When the metals react with acids, all these metals, they are more reactive than hydrogen. They lie above hydrogen in the activity series. So they displace hydrogen to form the corresponding salt and hydrogen gas is released. We can even see this by seeing that Mg exists in the form of Mg2+. In acids we have H plus Cl minus, in this we have H plus SO42 minus and so on. So Mg reacts with Cl to form MgCl2 and hydrogen gas is released. This is nothing but the displacement of hydrogen from the acids. So in this case, whenever metals react with acids, they form the corresponding salts and hydrogen gas is released. So the reaction of metals with acids releases hydrogen gas. At the same time, metals can also react with bases. So now, metals like zinc, lead, aluminium, they react with bases like sodium hydroxide. In this case also, they displace the hydrogen. So they form complex salts like Na2ZnO2 and hydrogen gas is released. So whenever metals react with acids or bases, they form a salt and hydrogen gas is released. So in all these cases, hydrogen is the gaseous product. Metals react with acids to release which gas? So whenever metals react with acids, a displacement of hydrogen takes place, hydrogen gas is released. So the metals, when they react with acids, they release hydrogen gas. Laboratory preparation. Now we have seen so many methods to prepare hydrogen gas. But which method do we use in the laboratory for the preparation of hydrogen? Let's see. This is the method. The reaction of zinc with an acid, that is HCl, it forms ZnCl2 and hydrogen gas is released. So we use this method in the laboratory for the preparation of hydrogen gas. Why we particularly use zinc and not any other metal? Because zinc has an advantage over the other metals. Zinc does not react violently. Some other metals like potassium, magnesium, they undergo very explosive and violent reactions. So zinc does not react violently. It is not very expensive and no other reaction takes place along with this reaction. So we prefer zinc over all the other metals because of these three reasons. Now in the laboratory, this is the experimental setup. It looks very complicated. We'll see this step by step, but it shows that we are using different solutions and a lot of impurities like these gases are present as impurities. H2S gas, carbon dioxide gas, water vapor, they are the impurities. So we have to remove them in order to get pure hydrogen. So let's see this setup step by step. So in the first step, we have impure hydrogen. It is passed through AgNO3 silver nitrate solution. So at times, there are trace quantities of arsine or phosphine which might be present in the atmosphere, etc. These arsine and phosphine, they are absorbed by silver nitrate. So in the first step, these two are removed. Now, these gases have to be removed, that is H2S, CO2 and H2O. In the second step, we use lead nitrate solution. Lead nitrate absorbs all the hydrogen sulfide. So in the second stage, we have removed all the hydrogen sulfide which is present as impurity. In the third step, we use potassium hydroxide. KOH undergoes a reaction with carbon dioxide. It reacts with carbon dioxide and absorbs all the carbon dioxide. So now there is only one impurity, that is water vapor. So in the last step, we use anhydrous calcium chloride. Anhydrous calcium chloride has a special property of absorbing all the moisture, all the water vapor. So in the last step, all the water vapor is absorbed by anhydrous calcium chloride. So what we get is pure hydrogen gas. So in order to get pure hydrogen, these are the various steps and solutions that are taken. All the impurities, all the gaseous impurities can be removed, and in the end we get pure hydrogen gas. Now let's look at the industrial preparation of hydrogen. How do we prepare hydrogen at an industrial scale? In industries, carbon is the reactant or the reagent which is used. Carbon is comparatively cheaper than other metals. So in industries, we use carbon. It is made to react with water. It forms a mixture of carbon monoxide and hydrogen gas. This mixture is known as water gas. Do not confuse water gas with the gaseous form of water. H2O in the gaseous state is not water gas. Water gas is a mixture of carbon monoxide gas and hydrogen gas. So in the first step, two gases are formed, but we need only hydrogen. So we have to remove all the gaseous products. So now we have to remove this carbon monoxide. So in the second step, this water gas mixture is made to react with water. It forms carbon dioxide, and again hydrogen gas is released. Now this carbon dioxide is an impurity because we do not need two gaseous products. So we have to remove carbon dioxide. Carbon dioxide is removed by taking potassium hydroxide solution. KOH reacts with CO2 to form K2CO3, which is a solid compound, and water, which is liquid. Now if any trace amounts of carbon monoxide is still left, it is made to react with water and CuCl. It forms a complex product, CuCl.CO.2H2O. So if any amount of carbon monoxide is still left, it is removed by this reaction. So we remove all the carbon dioxide in this reaction. We remove all the carbon monoxide in this reaction as well as some of it in this reaction. So now all the products are either in solid state or liquid state except the only product, hydrogen. So hydrogen is the only gaseous product which can be easily collected. This is the industrial preparation of hydrogen. This method produces hydrogen at a large scale, and this particular process of preparation of hydrogen is known as Bosch process. So this is the industrial preparation of hydrogen. These are the different techniques by which we can prepare hydrogen gas.